Picture yourself walking through the savannah, alone, night. Somewhere ahead, bushes are burning. Lightning struck a few hours ago. Heat, crackling, the smell of scorched fur from animals that fled the flames. And then you notice something, a burning branch. And instead of running, you stop. What happens next, we don't know exactly. But somewhere in a moment like that, one of the longest and most consequential experiments in the history of our species began. Fire. The only force of nature that humans didn't just survive, they took it for themselves. And it made us who we are. Fire is the only force of nature that humans didn't just use, they tamed it. Let's start with a question that sounds simple but isn't. When exactly did humans first begin using fire? Here it's important to distinguish two fundamentally different events. The first, using fire. Taking fire that's already burning in nature, from lightning, a volcano, spontaneous combustion, and keeping it going. Not creating it, but carrying and maintaining it. The second, making fire. The ability to produce fire on demand at any moment from available materials. These are two completely different levels of control, and between them lies a gap of hundreds of thousands of years. Let's look at the first. In June 2026, a study was published in the journal PLOS One that rewrote the timeline of fire use. A team led by Dr. Leora Kolska-Horwitz of the Hebrew University of Jerusalem, working alongside Professor Michael Chazin of the University of Toronto, applied a new analytical technique called bone luminescence to burned bones from Wonderwerk Cave in South Africa. The result? Traces of fire inside the cave date back 1.79 million years. That's not a typo. Almost 2 million years ago. What makes the finding airtight, the burned bones were found 30 meters inside the cave, far beyond where any natural wildfire could have reached. There are no guano deposits in that layer, ruling out spontaneous combustion. And nearby, early Acheulean stone tools associated with Homo erectus. The researchers' conclusion is careful but precise. Homo erectus wasn't making fire. They were capturing it from natural wildfires outside and maintaining it inside the cave. 1.79 million years ago, Homo erectus was carrying fire into a cave and keeping it burning. This is the oldest known evidence of fire use. Think about what this means. Carrying a burning branch into a cave isn't a reflex, it's a plan. You have to understand that the burning branch is valuable. You have to figure out how to carry it without getting burned. You have to know that fire needs feeding, more fuel, shelter from the wind, protection from water. Researchers suggest that owl pellets, the compressed remains of digested rodents, may have served as prehistoric tinder. Barn owls roosted in the cave, leaving layers of highly flammable material on the floor. Homo erectus may have learned to keep the fire going by adding exactly that. To tend a fire is already culture. It's the transmission of knowledge. Watch how this is done, or the fire will go out. Now, the second question. When did humans learn to make fire? In December 2025, a study published in the journal Nature became an immediate sensation. A team led by Nick Ashton of the British Museum described findings from a Paleolithic site called Barnham in Suffolk, England. The layer dates to roughly 400,000 years ago. It contains baked clay, heat-fractured flint hand axes, and, crucially, 2 fragments of iron pyrite. Pyrite, the mineral nicknamed fool's gold. Strike it against flint and sparks fly. That's the mechanics of a lighter. The key argument? Pyrite doesn't occur naturally in the geology around Barnham. It was brought there deliberately. Which means someone knew this stone was needed, understood why, found it somewhere else, carried it to the site. That's a multi-step, goal-directed action with a delayed payoff. 400,000 years ago, pyrite plus flint equals sparks, the oldest known evidence of deliberate fire-making. Before this discovery, the earliest confirmed evidence of intentional fire-making dated to around 50,000 years ago, from Neanderthal sites in northern France. Barnum pushed that boundary back by 350,000 years. Who was using pyrite at Barnum? Almost certainly early ancestors of the Neanderthals, not Homo sapiens. The ability to make fire emerged before our species existed. An important caveat from the researchers themselves: the development of fire control wasn't a linear process. Groups of hominins learned to make fire and lost that knowledge, then rediscovered it. The skill didn't pass down automatically. It died with the people who carried it. This isn't a straight line of progress. It's thousands of separate discoveries scattered across time and space. And now, a question I'd genuinely love you to leave in the comments. Think back to the last time you lit a fire. A campfire, a fireplace, a grill, a candle. What did it feel like? Something particular, or nothing at all? Because according to research in psychology, most people sitting by an open fire experience something they can't quite explain. A pull, a calm, an inability to look away. That's not an accident. That's 2 million years of inheritance. Drop it in the comments. What do you feel when you're near fire? I'm genuinely curious. Let's look at what fire did to our bodies. Richard Wrangham, professor of biological anthropology at Harvard University, published his book Catching Fire: How Cooking Made Us Human in 2009. His central argument: fire and the thermal processing of food were the primary engine of human evolution. Not hunting, not tool-making, fire. Here's the logic. Raw food is enormously expensive to digest. The primate gut is a costly organ, consuming around 20% of the body's total energy expenditure. In humans, the gut is significantly smaller than you'd expect for a primate our size, roughly 60% of what the formula predicts. Cooked food digests more efficiently. Starch gelatinizes under heat, making it far more accessible. Protein denatures, breaking down more easily. A cooked egg is over 90% digestible, a raw egg only 50 to 60%. Smaller gut leads to less energy on digestion, leads to more for the brain. This is precisely what happened with Homo erectus. Around 1.8 million years ago, brain volume jumped by 42% compared to its predecessor, while teeth and gut shrank. This is known as the expensive tissue hypothesis. Expensive tissue, gut, giving way to even more expensive tissue, brain. Fire cooked our food and grew our brains. The gut shrank. Neurons took its place. But Wrangham goes beyond anatomy. Cooking isn't just chemistry. It's a social revolution. Once you have fire in a shared pot, you're forced to negotiate. Who hunts? Who cooks? Who watches the fire while others sleep? Who eats first? Wrangham argues that fire laid the foundations of human pair bonding. When a woman cooks food, she needs protection from other men who might take it. The man who provides that protection gets guaranteed access to cooked meals. From that mutual dependence, the family emerges. This is speculative. Wrangham himself admits there's no direct evidence, but the anatomical and chronological coincidences are striking. Fire changed not only what we eat, it changed when we're awake. Before fire, night was predator territory. After dark, every primate preferred to climb as high as possible, into a tree, onto a ledge, and stay still. Activity ended at sunset. Fire changed that rule. Predators fear fire. A visible flame can be seen for miles. It signals, something here knows how to do what you can't. Suddenly, humans had evening hours. A few hours between sunset and sleep when it was safe to move, to talk, to think. What happened during those hours was studied by Polly Wiesner of the University of Utah. She spent 174 days with the Jew/Hawansi of the Kalahari, hunter-gatherers of Botswana and Namibia, recording conversations during the day and at night around the fire. Her findings are striking. Daytime conversations among the Kung, roughly 3/4 were practical matters: where to hunt, what to gather, who owes what, and gossip, criticism, complaints. Businesslike, tense, conflict-laden. Nighttime conversations by the fire, over 80% were stories about people in distant groups, adventures, spirits, the funny and the strange, singing, dancing, trance. Wiesner writes, "There's something about fire in the middle of the darkness that bonds, mellows, and also excites people. It's intimate." The firelit night was the space where daytime conflicts dissolved, where people who'd argued in the morning sat beside each other in the evening, where knowledge that couldn't be transmitted in the rush of the day got passed on, where stories were born. Fire gave humans the evening, and the evening gave humans culture. There's a reason our fascination with fire isn't random. Christopher Lynn, an anthropologist at the University of Alabama, studied the physiological response to watching fire. His finding? Watching fire lowers blood pressure. The longer you look at the flames, the stronger the relaxation effect. Being around others at a fire amplifies it. Lynn calls this the fireside relaxation hypothesis, the idea that after hundreds of thousands of years by a campfire, humans developed a deep physiological response of calm in the presence of flames. You don't stare into a fire because it's pretty. That's an ancient, self-soothing program built into your nervous system. Here's something that rarely gets talked about. Let's go back to Wonderwork Cave. Homo erectus carries fire in from outside and keeps it burning inside. How long could they maintain a single fire? We don't know exactly, but ethnographic data suggests some hunter-gatherer societies kept one fire going for months, traveling with smoldering coals carried in special containers. Fire was a living thing they tended. They fed it, protected it, shared it. In some Aboriginal Australian languages, the word for hearth and the word for home are the same. And how exactly did friction firemaking emerge? When did someone first accidentally notice that rubbing wood against wood produces smoke and heat and a spark? We don't know. It doesn't leave a trace in bones. You can't see it in cave sediments. But we do have something else. Every known method of friction firemaking, the hand drill, the bow drill, the fire plow, appears in cultures on every continent, not because it was invented once and spread, but because this solution was discovered independently over and over again. Friction makes heat, heat makes char, char ignites tinder. It's a discovery waiting for anyone who watches long enough. Friction firemaking was discovered thousands of times, independently, on every continent. That means it isn't a coincidence. It's logic. Let's look at what fire did to our brains directly, not through food, but through time. Wrangham calculated that a chimpanzee spends around 6 hours a day chewing raw food. A human eating cooked food, around 1 hour. 5 hours a day, every day. Over a year, that's more than 1,800 hours, time that became available for other things. For what exactly? Making tools, social interaction, transmitting knowledge, telling stories by the fire, sleep, play. 5 freed up hours a day. That's the raw material of culture. One last thought. What does a person think about when they watch fire? Christopher Lynn asked research participants exactly that. Most answers converge on one thing. Nothing in particular. Thoughts drift. The past surfaces, people nearby feel closer. Wiesner describes it more precisely. By a fire, a person stops thinking about today's problems and starts thinking about something larger, about people who aren't there, about what has been, about what will be, about what doesn't even exist, spirits, gods, meaning. Fire is the first meditation of our species, and maybe that's why we still can't look away from a candle flame. And a second question for the comments. Do you have a fire memory? A campfire, a fireplace, a candle that meant something to you? A conversation, a moment, something you still think about? Because if what we know about firelit nights is right, those are the stories that matter most. The ones born in darkness, next to a flame. Leave it below. I genuinely want to read it. Let's go a little deeper on a few things that deserve their own look. First, fire and sleep. Before fire, human sleep was light and anxious. Night was predator time. alert and ready to wake, not a habit, but an evolutionary defense. Fire changed that. A steady source of light and warmth reduced the threat. Someone had to watch the fire, which created the first shift system in human history. One person stays awake, everyone else sleeps deeply. Researchers suggest this, the ability to sleep deeply and safely, partly explains why humans sleep less than other primates. Chimpanzees sleep around 9 to 10 hours, humans 7 to 8. But human sleep is richer in REM phases, where memory consolidation and information processing happen. Fire isn't just warmth and protection, it's qualitatively different sleep. And different sleep means a different brain. Second, fire and power. Whoever controls fire is powerful. That was as true for our prehistoric ancestors as it is today. Control of fire created the first social hierarchies based not on physical strength, but on knowledge. Knowing how to keep fire going was expertise. Knowing how to make fire was even more valuable. In some hunter-gatherer societies, the right to light a ritual fire belonged to specific people, elders, shamans. Fire became a symbol, a metaphor for the transmission of life, connection to ancestors, contact with the invisible world. We still light candles in places of worship. We still carry the Olympic torch. We still maintain an eternal flame. These rituals stretch back to a depth we can barely imagine. Third, fire as the break from the animal world. No other animal uses fire intentionally. Some birds, so-called firehawks in Australia, have been observed picking up burning sticks and dropping them to flush prey from vegetation. But that's opportunistic. It isn't control, and it isn't maintenance. Fire is an absolute boundary. On one side, every living thing that flees from flame. On the other, one species that picked it up. This isn't a metaphor. It's a literal bifurcation point in the history of life on this planet. No animal maintains fire, only us. That's the line that makes us, us. One last personal note. Wrangham has described in interviews how the idea for catching fire came to him while sitting at home by his fireplace, watching the flames. He sat there looking at it and suddenly thought, I'm looking at exactly what people looked at 2 million years ago. The same flame, the same dance of shadows, the same darkness all around. And in that darkness, the same questions that haunt us now were being asked. What's out there? What came before us? What comes after? Fire didn't just warm the body. It created the space in which a thought could exist, a thought larger than tomorrow's hunt. Maybe that's why every great religion and philosophy circles back to fire as an image. Prometheus stealing it from the gods, the burning bush, the eternal flame of Zoroaster. The Buddha's enlightenment, literally awakening, like a flash of light. Fire is humanity's first symbol, because it's the first thing that made us separate from everything else. And maybe that's the answer to our pull toward flames. We look at fire and feel something we don't have an exact word for. Ancientness, belonging, recognition, because fire remembers us longer than we remember ourselves. Fourth, fire and language. Robin Dunbar, Emeritus Professor of Evolutionary Psychology at the University of Oxford, has proposed that the development of human language was directly connected to the campfire. His argument? In other primates, social bonds are maintained through grooming, physical care directed at each other. But grooming requires direct physical contact. You can only groom one individual at a time. That places a hard ceiling on group size. Language allows social bonds to be maintained at a distance, and, crucially, simultaneously. One person speaks, everyone listens. It scales. Dunbar suggests that evenings by the fire, when darkness made gesture useless, but voice could carry across an entire camp, became the space where language developed its social dimension. Not for transmitting practical information, for maintaining relationships, for telling stories. Fire created an audience, and the audience created the storyteller. Fifth, fire and tools. Around 164,000 years ago in South Africa, people discovered another use for fire: heat treatment of stone. By around 70,000 to 72,000 years ago, this practice had become widespread. Heating silkrete or flint to a specific temperature, then cooling it slowly, changes the material structure. It becomes sharper, more workable. Blades made from heat-treated silkrete are significantly sharper than untreated ones. Cutting force increases substantially. This required understanding the physical properties of materials, planning several steps ahead, and passing the technique from person to person. This isn't fire use anymore. It's engineering. Fire stopped being a source of heat. It became a tool for making tools. Fire to cooked food to bigger brain. Fire to heat-treated stone to better tools. One invention, double payoff. Sixth, fire, warfare, and migration. Fire made it possible to live where survival had previously been impossible. The cold nights of Europe, the brutal winters of Central Asia, the frozen plains of the glacial zone. Without fire, death. With fire, life. The migration of Homo sapiens out of Africa into Europe and Asia around 60,000 to 40,000 years ago would have been impossible without fire as a fundamental survival technology. Fire was a literal passport into the cold world. And at the same time, fire is a weapon. Controlled burning, setting fire to vegetation deliberately, allowed humans to drive animals toward hunters, clear land, create space for camps. The first landscape management in history. To sum up, fire isn't one invention. It's a chain of transformations, each one changing what we are. Fire use leads to protection from predators, warmth, the ability to inhabit caves. The cooking revolution leads to smaller gut, bigger brain, more energy, less time chewing. Evening hours by the fire leads to language, stories, culture, religion. Heat treatment of stone leads to more advanced tools. Carrying fire into cold climates leads to global migration, the human settlement of Earth. No other invention in human history had this kind of layered, long-range effect. Because everything else, the wheel, ceramics, metal, electricity, only became possible because roughly 2 million years ago, someone stopped in front of a burning branch and decided not to run.